if you're gonna graph these inequalities, couple things to first go over. If you have a plain less than symbol or a plain greater than symbol, that's the same thing as using an open dot. And if it is less than with an equal to sign or greater than with an equal to sign, if it's underlined, then that's a solid dot. So a couple other small things, I guess, is just a reminder that if you have this inequality, when you open that up really big, it makes the letter L. So when you read that, L, less than. And so this one does not make an L, so that one's greater than. Okay, so if I'm gonna graph this, it says my numbers are X's, my numbers are bigger than, greater than 3, or my numbers are smaller than or equal to 1. First thing you wanna do is go onto your number line and put either a solid dot or an open dot based on whether there's an underline. So I'm gonna take at 3, since there's no underline, I'm gonna put a dot with an open. And then this one here at 1, because there's an underline, I'm gonna use a solid dot. Now, if my numbers are bigger than 3, the numbers bigger than 3 are to the right of 3. And then numbers that are smaller than or equal to 1, numbers that are smaller than 1 are to the left. So every number, -4, -3, -0.5, the number 1, all of those numbers make this true. The number 3 itself does not make this true. That's why it's an open dot, but everything just barely after 3 does make that true, like 3.000001 is a part of the solution. Okay, so then this next example, X is less than 3 and X is greater than -2. So first thing I'm gonna do is have a number line. I'm gonna go to the number line at 3 and at -2 and put open dots because those are not underlined. Now numbers that are both, because the word and, numbers that are both smaller than 3 and bigger than -2 are the numbers in between. For example, the number 1 is smaller than 3 and 1 is bigger than -2. The word and means the number is a solution if it works in both. When it's an or solution, the number is a solution if it works in at least one of them. Okay, so here's just 2 more examples. I'm gonna go to my graph, and because these are underlined, I'm gonna put solid dots at 0 and 3. When I'm reading that, my numbers are less than or equal to 0. So my numbers are smaller than or equal to 0. Numbers that are smaller than 0 are to the left. My numbers are bigger than or equal to 3. Numbers that are bigger than 3 are to the right. And again, or means it makes this one true or this one true. Okay, last example. Okay, going to -4, I'm going to put an open dot because it's not underlined, a solid dot because it is underlined. Okay, so here we are at -4 and at 3. But and means the number has to make both true, not at least one true. So the number 1, for example, is bigger than -4, and the number 1 is smaller than or equal to 3. So 1 makes both of them true, so 1 is a part of the answer. But if I pick a number like 4, 4 is bigger than -4, but 4 is not smaller than or equal to 3. So again, the word and means it has to make both true. So all the numbers in between here make it true. Now just an observation that you might make, and I'm gonna give you a shortcut on the simple ones, but the reality is this shortcut does not always work in the special cases. Okay, so if you are rowing your boat, and another word for paddles are oars, So when you have an or, the arrows go out like paddles. Ors go out. And so then the ands connect up. Now again, that's going to work in 99% of them. The ones you guys are facing, frankly, it's going to work in all of them. But when you're in doubt, when it comes to special cases, you just take a number like, for example, a number in between here like 1, and the word and means it has to work in both. And if it doesn't work in both, then you know that you shouldn't have connected it in the middle. And an or statement, you take a number like -2 and you put it into both, and it just has to work in at least one of them.